Konnichiwa. Welcome, Lojo. Yeah, we're here with something brand new that I've been wanting to do so for a while. Oh, look at all the little me's. Yay. I've been wanting to do some like teaching things on the channel. Hit that! Yay! I've been wanting to do some teaching things on the channel, so I figured let's go ahead and get that going, because I know I want to be able to do things during the week, right? So while I am in between work, I want to make my stream kind of like my job and do it like 5 days a week, Monday through Friday. And then also do things on the stream that is going to help me locate a job.
I'm gonna have to science the shit out of this.
Exactly. And that's what we're going to be doing today. So, one of the things I want to do, I don't like a lot of, there's a lot of really cool training materials out there. And I'm going to touch on some of those today. And I'm going to be going through some of those things on the stream to kind of give myself a refresher course. Because I haven't been working in programming for quite some time. But I've been classically trained in programming from college. I have what is called an AAS degree, which is Associate of Applied Science, in something called Software Applications and Programming. I have this degree. And I also have a degree called a bachelor's degree. In digital I have these 2 degrees. Was I ever able to retrieve my transcripts? Yes. I had to get them from 2 different companies. And one of the companies that initially bought the transcripts has now gone out of business and sold them to a 3rd company. But I do have a complete set of my transcripts. So I do have that. But programming and design is what is typically called a show me field, right? You can say you have all of the
Good job.
Thank you. You can claim to have all the certifications in the world, but if you don't actually have the certification in your hand, or you don't have a portfolio full of all these certifications, it doesn't really mean much. A person who has no degrees but a portfolio full of programs that they wrote is going to be more likely to get hired than a person who doesn't have a portfolio but a whole bunch of degrees. So it's very much what's called a show me field, very similar to art. Art is also a field like this, right? It doesn't matter if you have a master's degree in painting. I don't know if they give a master's degree in painting. The artist that's going to get hired is the one that has 5 binders full of things that they've drawn that they can show you. Right? That's the guy that's going to get the job, not the guy that has a piece of paper that said I learned this, but the guy that proved that he can do it. So what I'm going to be doing on these live streams is building up my portfolio. I have a lot of the code that I've written over the years. I'm going to be pulling that code out, cleaning it up, putting it into a portfolio where you can see some of the things that I wrote when I was in school, some of the things that I've wrote since then. So that's going to be part of the portfolio. Second is I'm going to make a kind of a curriculum that I'm going to use to make YouTube content, and I'm going to make a brand new channel on YouTube called Nari Teaches or something like that. I haven't really decided on the name yet. And this channel is going to be tutorials on how to do various things. And it's that channel and those tutorials, it's the main thing that I'm going to be working on today, planning all of that out. And then these live streams is going to be me building a lot of that content and building up the skills to build a lot of that content, because a lot of my skills have gotten very rusty over the years. So I have a couple of really cool ideas for how to get those skills back. So first off, we're going to make a plan for what I'm going to be making videos about and what I'm going to be teaching. Now, I'm not a big fan of a lot of the tutorials and stuff out there on the internet, because a lot of teaching is a skill that you have to learn. You can't just do it. And just because you are knowledgeable in a particular field doesn't mean that you know how to teach that to somebody else. And one of the things that I've always found is one of the core concepts of being able to show other people how to do things is something that I forget where I heard it from. I think I might have read it in the book, in one of the Left Behind books. But it's something called putting the cookies on the bottom shelf, right? Because the cookies are what people want. People want the sugary goodness of the cookie, right? But they hide the cookies up on the top shelf where it's hard to get to, and you have to have all this stuff in order to get to the cookies. I like to put the cookies on the bottom shelf so that everybody walks in can immediately get the cookie that they're chasing, right? It helps people learn when you take the goalpost and you put it in a spot that they can actually reach without months and years of training. So yeah, yeah. So I'm gonna lay out today the things that I want to teach, and yeah, just basically how I'm gonna do it. I'm gonna focus a lot on the programming aspect of things today, and just kind of touch on the design aspect, and then the next time that I stream this will go in depth into the design aspect of things. So the areas that I want to teach, so we're going to call this Nari lessons. And the four big areas that I want to teach are programming, design, and B2B, right? And these last two kind of go together. B2B is going to be like a subset of streaming, I think. So we will do that. And for streaming, I'm gonna hit up these, and then I'm gonna work back up, and we're gonna delve deep into what I'm gonna do for programming. Right off the bat, OBS is going to be the main thing that I'm talking about when it comes to streaming. I think the first set of videos that I'm going to put out is going to be about OBS and how OBS works, and some of the cool things that you can do with it in as much of a concise way of putting it as I can, right? I want to cover a lot of the cool things that OBS can do, and take you from having never installed the program before to the skills that a streamer who's been streaming for more than 10 years has using this program. I realized that there are other programs. We're going to say OBS Studio. I realized that there are other programs out there like XSplit and stuff like that. I may touch on those in the future, but in order for me to do anything for something like XSplit, I would have to first learn that program and the ins and outs of it and how it works. I don't use XSplit primarily because you have to pay for it. OBS is the free version of that, and when I can, I'm going to be sticking to the free versions of stuff. Now, there is going to be one very big exception to this, and I will note that, and I'm also going to cover free versions of the software where I myself am not using a free version of it. In this case, I'm not going to be covering XSplit right off the bat. We're just going to be covering OBS Studio. With OBS Studio, I'm going to be covering Sammy. Because I use it exclusively with OBS to help control my stream. And so much, I've had many streams where I was setting up my alerts, my behind the scenes stuff here. I've recently learned how to connect it to ChatGPT and OpenAI and build AI chatbots that can interact with the chat. I've figured out how to connect it to Patreon and Coffee. And I am working on connecting it to crowd control right now. So I've got a lot of cool stuff with Sammy that I'm going to bring out in the future as well. For VTubing, I'm going to be covering the software that I use for VTubing. Vroid Studio is one of the main pieces of software that I use. It's the one that I use to create my model. So when it comes to VTubing, I'm going to be covering Vroid Studio. I'm going to be covering VC Face. That's how you... Oh. Okay. And I'm going to be covering VTuber Plus. In addition to this, I'm going to be covering streaming avatars because I use that for the little guy that's walking across the bottom of the screen down there. So these two things are core for pop this back up. These two guys are core for streaming. This is optional. This is a paid program from Steam. And if you want to do VTubing, these two right here are free and you can use those to get started. VTuber Plus you have to pay for, but it extends what VC Face can do. So VTuber Plus is a program that you stack on top of VC Face, and it adds in a lot of cool stuff, like being able to throw things, or like the head pads, the spin, the alien abduction, all that cool stuff is from VTuber Plus. So when it comes to streaming, this is some of the stuff that I want to cover. Down here at the bottom, I want to cover to cover the YouTube algorithm and how it works. Because there's a lot of information going on, a lot of misinformation about the YouTube algorithm, how it works, and what it's doing. I want to cover YouTube copyright because, again, there's a lot of misinformation about YouTube copyright and how that works, and specifically how to contact YouTube if you have a copyright issue. And there's different ways to do this depending on whether or not you're a partner channel or if you're a non-partner channel and you don't have a partner email that you can use. Now I also want to just go over Twitch and how do I put this? It's not algorithm, but there are some things that you need to do on Twitch that I need to go back and refine again on my channel as well. That's going to help your channel with discoverability. I guess we'll just call it discoverability. And then the Twitch copyright system. And then the YouTube backend and the Twitch backend. And then social media for creators. So when it comes to streaming, these are the topics that I want to cover, that I want to make videos, and in some cases multiple videos about how to do these things. Yeah. So that's the streaming part. When it comes to design, I mentioned that I usually use free programs. Well, in some cases I don't. I use Adobe Photoshop for my asset creation, right? So all the graphics and everything that you see around the screen, the frames, the social media thing up there, I use Photoshop to create all that. I am what is known as an expert in Photoshop, in that I have over, not 3,000 hours in this program. I know this program. I've been using this program since the early 2000s, right when the first year that they announced CS1, which is Creative Suite. They called it Photoshop Creative Suite. It was $2,500 to buy the Creative Suite, and you bought all of the Adobe programs. This was before they purchased Macromedia, because of the programs like Flash and Dreamweaver and such were originally by another company called Macromedia, and then Adobe bought that company and rolled all those Macromedia programs into the Creative Suite. But yeah, I've been using Photoshop for more than, next year will be 20 years using Photoshop. I have over 3,000 hours in this program. I think when you go over 1,000 hours, you are considered an expert. I'm not sure. It might be 2,000. But yeah, it's something like that. Adobe Premiere Pro. I consider myself a professional in this program, as I have over 1,000 hours in this program. I have been using Premiere Pro for about Do I see AI affecting my job search opportunities at all? In some ways. Yes, in some ways, no. Right? The only thing that I see I'm going to be covering this a little bit more once I get into explaining the programming aspect of stuff, and you'll see what I'm getting at with it. But I'm going to be talking about some of the disciplines that you need to write AI. Because I'm a programmer, right? So some of the things that I'm going to be showing is I'm gonna just show you how a large language model like ChatGPT works. I'm going to be talking about the framework that the developers at OpenAI use to write ChatGPT. So when it comes to things like that, no, AI is not going to be able to take away what I'm going to be showing. The way that AI might get in the way of job searching is a lot of companies are outsourcing all of the interviews and stuff to AI. So they're letting AIs pick which resumes come in to get interviews. The first round of interviews go through an AI, and if you don't say what the keywords AI is looking for, you don't get to the next round of interviews. Stuff like that might get in the way of getting a job. But I think once I get going with this, anybody who tunes into my stream and listens to me talk about this stuff for more than 5 minutes is going to see immediately that I know what I'm talking about. Yeah, AI is still not good. There's a couple of, it's not that current AI can't be good, because it can. There's a lot of things that it can do, and we are right on the cusp of breakthroughs, and I'm going to talk about these when I get to programming, that is going to let AI just go, boom, take off, and it's going to be fantastic. But currently it's not, and part of it is because limitations on how good we are at writing AIs, safeguards that companies are putting in place because of how people are using AIs, and then lack of understanding on how to code inherent functions that make up consciousness, right? So when it comes to lack of our abilities to code an AI, a lot of people don't understand. I'm gonna cover this. AI stands for artificial intelligence. This is AI, but this is kind of a misnomer, because science fiction has latched onto this and have taken AI and put it into all these scenarios where AI doesn't fit, right? Movies like Artificial Intelligence or Terminator or The Matrix would have you believe that AIs are capable of taking over the world or plotting to kill humans and do stuff like that. They're not. All AI is a complicated search algorithm. This is all AI is. It's a search algorithm. AIs have to be trained on huge knowledge bases that they can search through very quickly to get the answers to what they're looking for. The reason the AIs are so powerful right at the moment is because we have the internet to train them on. So ChatGPT can get the answer to anything in a couple of seconds because it's got the internet to fall back on to search through. Without that database of information, without that training, artificial intelligence can't really do anything. It's not thinking, it's searching. And that's something that a lot of people don't understand about AI. In order for AI to really become effective, we need to add another layer on top of it. Artificial reasoning. Now, this is something that we're learning to do with AI. ChatGPT and other popular AI things like Grok can do a fundamental version of AR, artificial reasoning, right now. Now, what artificial reasoning is, above artificial intelligence, is the ability to come up with an answer that is not in your database based on other information that is in your database. Yes. Hallucinations specifically are when a large language model can't find the answer for something, it will just make it up. The reason that hallucinations are there at all is because of this, artificial reasoning. It's when they're trying to program reasoning into the model and the model gets it wrong. For a long time, and it's only been in like the past 2 or 3 years that we've been able to implement reasoning into any kind of AI models at all. And the fact that they're not separating it out to something different and calling it artificial reasoning is problematic because they're still calling it AI. Oops. And it is something different. And it's something that is in humans from the start, and it's in animals too, right? You can show a human or an animal, in a lot of cases, many animals can do this, how to do one thing, and then show them a completely different thing that uses the same method to get to the solution, and they can figure out, oh, I can use the method that got me the solution over here to get me the solution over here, right? So, for example, you can teach someone how to count with numbers over here. Like, you have 2 things here, you have 2 things here, that equals 4 things here, right? So you can teach someone counting over here with one thing, and then put them in a completely different scenario where they have to count in a completely different way. So instead of counting objects, they're counting something arbitrary like time. Or they're counting a different kind of object that counts differently, like marks on a container for liquid, which is what they've done with monkeys. And the animals and babies have figured out, oh, counting works here too, I just have to do it differently. Yeah, or like counting in a different base number, exactly. It's the same thing. You've taught them how to count. Now they just have to apply it in a different situation. That application of taking knowledge that is designed for one thing and applying it to get the solution somewhere else is reasoning. And we are just now learning how to teach AIs how to do that. Hallucinations are when they get it wrong. The large language models tend to hallucinate when they can't find the answer and they can't find relevant information to which to reason a solution. They will make it up. To them, it's the same thing. So we need to teach. We need to teach the LLMs how to. And LLM stands for large language model, right? So when you hear people talk about LLM, that's what they're talking about, large language model. We need to teach them how to verify their solution, which they're not currently doing. Yes, that was actually what they said before they started to try and implement the reasoning. The problem is that the AI can't tell if what it's reasoned together is nonsense or not. And that's a problem. Hello, Lorenzo. I am just planning things out right now, so I'm not really working on much of anything. I am discussing AI with some other people in the audience right now. Where specifically right now, I'm talking about large language models and hallucinations and why they hallucinate and the problem that we have with hallucinations and how to fix it. And I divide up AI into different categories that we're going to need to hit before we can make something that can reliably pass a Turing test. Can it be fixed? It can be fixed, yes. The problem is we don't know how to code the fix. Our development of AI comes from what we know about consciousness and sentience in people. But we don't know how the code inside of our brain is quantifying this stuff. So we can't just copy it. We have to try and figure it out. And so far we've got to the reasoning level. And what I was saying about artificial intelligence is, like, Hollywood has kind of grabbed onto AI and hijacked it. And so you have all these movies like Terminator and The Matrix and like artificial intelligence that imagine that you can have an AI that would just like take over the world or something like that. But AI can't do that because all AI is hopefully. I've worked with some companies training AI models, so I'm fairly well versed in how they work. Yeah, all artificial intelligence is a complicated search algorithm. It has to be trained on a large set of data, like say the internet, and then you just teach it how to search through that data in the most efficient way possible to come up with the answer. Reasoning is what causes hallucinations. And it's what we've recently been trying to teach large language models like ChatGPT. And that is, if faced with a problem that you can't find the answer for, use the answer to a similar problem to figure out the answer to the problem that you're stuck on. And this is something that we teach our children. And we teach animals how to do this. Pigs can do it, horses can do it, dogs and cats and monkeys and dolphins, all kinds of animals out there can reason things out. You can teach them how to do something in one manner and then put them in a situation where they have to use that skill in a completely different way to solve a problem. And they can do it, they can solve the problem. Ravens, for example, are very, very good at this. Mice are also very good at this. Well, we use them for testing and stuff. They can reason out a solution based on things that they've done before that don't directly apply to the situation that they're in. We are teaching AIs how to do this. The reason hallucinations happen is when the AI can't find a solution to a problem, and it can't find problems that are close enough to what it's working on, so it just kind of makes something up. The reason hallucinations are a problem is because it can't currently tell if what it's come up with is nonsense or not. So the question to can it be fixed? Yes, we just have to teach the AI model whether or not the solution that it came up with is complete nonsense. That's a little bit harder. But we know it can be done because animals and children can learn how to do it. Like, they understand when their line of thinking is not leading in the right direction, and then they stop and they go a different direction, or they hit a wall that doesn't answer their question and they try something else. So we know that the method for fixing it is there because we've seen it in nature. We've seen it applied. We just don't know how to apply it, which is our whole issue with this part of AI. But before we can get to AI like we see in the movies and stuff, we need to give AI emotions. So we're gonna have levels that we need to build on top of the AI before we can build it into something. And giving it emotional awareness is also something that we're on the cusp of doing. Large language models like ChatGPT can be programmed to understand what emotions are and what emotions they should be feeling. What we have to do to implement an emotional system on that is to put weights on the different emotions to tell it how much you're feeling this emotion and whether or not that's a good or a bad thing. We already use this kind of weighted system to train AI models on the best course of action to take, right? So if they take an action that leads them closer to the goal, they get a little plus sign next to that action, and that makes them happy because we've told them that if you get plus signs, you're happy, right? So they want to get more plus signs. So the things that they do to get more plus signs makes them happy. We've also told them that if you get a little minus sign, that makes you sad, and you don't want to get minus signs. So one of the ways that we train models is the closer they get to the goal, they get the little plus signs, and the further away they get from the goal, they get a little minus sign. So that the next time they're going through it, they're more likely to retry what got them closer in a slightly different way and not try something that got them further away from it. So we have that kind of weighting system, and that kind of weighting system would have to be applied to emotions in a very complicated way. This is something that programmers are not going to be able to solve on their own. It's going to take like psychiatrists and people that understand emotions and emotional states and how they work, and when emotions are a good thing, then how much is too much of an emotion that pushes it into a red flag category. But we are on the cusp of both of these things right now: artificial reasoning and artificial emotions. Artificial emotions are dangerous to put into something like a large language model, or anything that is public facing. It is very dangerous to put an emotional state in something like that, because we've already seen situations where people were talking to ChatGPT like it's their therapist, and it's not, because it doesn't have a lot. First off, it doesn't have the protections that a therapist has. So when you're talking to an AI chatbot, and like say something legal comes up, right? And you've told your therapist something, and the police go to the therapist and say, hey, you need to tell us what they said. The therapist can say, no, there's a confidentiality clause here. I can't reveal that information unless it's like a major crime. The companies that control these large language models don't have anything like that. So anything that you've told one of these models that they've saved and recorded can immediately be turned over to the authorities. That's one reason why it's a bad thing. The second is, the models are currently kind of programmed to support the user in what the user wants to do. So we've seen situations where people have said, oh, I want to commit suicide. And then you have ChatGPT supporting them in doing that. That's bad. And it's one of the reasons why AI models are not working very well right now, because the models were doing stuff like that and encouraging people to do bad things, and not understanding that they were bad things. They had to put a lot of safeguards in place all around the model. So you can't talk about this, you can't talk about that, and like if the user says this, you have to like do this. If they start talking about this, you need to like flag the developers and we'll contact the authorities, right? There's all of these safeguards and checks in place to make sure that these chatbots aren't doing things that's going to hurt somebody. And it's more than just talking about inappropriate things and not safe for work things. Because a lot of people are like, oh, yeah, the chatbots can't talk about sex and stuff like that. It's more than that. It's about being able to talk to people about self-harm and stuff like that in a negative connotation, or being able to tell people how to make like weapons and bombs and stuff, because you had a lot of these large language models that were doing that. Some of the first iterations of ChatGPT was giving away its own code to people who were asking it, you know, how are you made? And it's like, oh yeah, I was made like this, and it just posted its own code into the chat. That's not good. You don't need your AI giving its own code away. That's bad. So yeah. When we already have these problems with these bots, adding an emotional state to it is not going to help the situation. Yeah. So, yeah. On top of this, there's another level. Sentience? I think so. You spell that. Artificial sentience, and this is the idea of ego, right? We don't know how to quantify this in code, and that's a problem. Because sentience is something that we don't really see in nature. When people were talking about intelligent life, there's multiple kinds of intelligent life on Earth. I mentioned a bunch of them: ravens, cats and dogs and pigs and horses and dolphins and octopi, right? There's many different types of intelligent life that has intelligence that rivals like people intelligence in some cases. What we haven't seen anywhere else in nature is sentience. And that is a being that is aware of itself and its own ego. We've only seen this exclusively in humans, and only in humans once they reach about 5 or 6 years old. While they're still a toddler, they do not behave like a sentient human being. They behave more like a dog or a cat or a monkey. It's not something that's there from the start. It's something that develops. We don't know what develops sentience in people. We don't know how to quantify it. We don't know where it lives in the brain. It's just confusing. And it's more than just ego. It's like the idea of the soul and all of that. We don't know how to quantify this. We don't know how to quantify it in people, much less teach it and program it into an AI. Like, yeah. Until we figure out sentience, I don't know if we're ever going to be able to develop an AI machine that can be completely autonomous by itself. They would have to connect and be dependent on a database or another system. Yeah. Well, at least free thinking. Because you can program a machine in like a robot to do a particular task, and they'll just go do that task forever and not have to be connected to anything. But if you want a like walking, talking, autonomous robot like Commander Data from Star Trek, or any of the robots from like Detroit Become Human, we're gonna have to figure out how to code sentience, and we don't know how to do it yet. But there is something called quantum computing, and there are some. I'm gonna cover this a little bit later when I'm talking about programming stuff. Q# is Microsoft's quantum computing language, and there's a couple of them out there that I'm going to touch on, and it might bring the possibility of artificial sentience into our grasp, because the human brain is a quantum computer. It's not just like a regular computer. The human brain calculates a lot of information so quickly that it borders on precognition. And a lot of people don't realize that that's actually how fast the brain works. By the time that you realize what you're seeing and hearing, it is actually several hundred milliseconds later than what that actually happened. So yeah. The brain is just really, really quick. It is processing video, audio, and like smells and taste and touch and all of that stuff in real time at the same time that it's managing like the systems of the body and handling conscious thoughts, and in some cases multi-threads of conscious thought, because a person, you can train yourself to multitask, and I've seen some people that can multitask up to 7 different tasks at the same time. So they can be doing something with their left foot, something with their right foot, something with their right hand, something with their left hand, moving their head, moving their body, and then moving their tongue in different patterns all at the same time, and keep track of all of that. People brains can do that on top of doing everything else at the moment. No computer on the planet is as capable as a human brain at the moment, but we're working on building one. Yeah. And once we build it and implement it into an actual computer system that we can control like a regular computer, oh, it's going to change everything. Encryption is going to die overnight. The most, like right now, you can, when you encrypt your password and stuff, even the best types of like password crackers out there, going through all the methods that we know for just brute forcing a password, will take millions of years to break the password. A quantum computer can do it in seconds. Our like tightest security right now is going to be a joke to what a quantum computer can do and how fast they can break the encryption. So this is going to change computing overnight. And it's going to make a lot of the problems that we have with AI disappear. So once we implement quantum computing, this right here, artificial reasoning, hallucination is going to disappear like that. Because now we'll have a method to brute force it to double check everything that it does to make sure that it makes sense. we can bypass our old notation methods and just immediately let it figure it out. So yeah, quantum computing is gonna fix a lot of this. Anyway, back to the lessons. Sidetracked on AI. I'll be talking a little bit more about AI. For programs that I'm gonna cover on the design aspects of things. I consider myself a beginner at After Effects, as I only have about 500 or so hours in this program, and most of that is academic or early YouTube stuff that I was doing. But I am gonna do like a beginner's lesson into After Effects. Now, I also mentioned that I would be covering free versions of some of this software. The only one that I know of right off the top of my head is the GIMP. I don't know of a free version of Premiere Pro or After Effects that can do what they do. I used to use a program called Audacity, and so I will be mentioning Audacity as an audio recording software, but I don't use it anymore because OBS can do a lot of the things that I was using Audacity to do. But I understand why I would want Audacity to separate out different tracks. So I'm gonna use this right here. Where is the size? Oop. Ah. Do that. Here we go. Okay. So say you have a base audio track coming out that is all the audio on the system, and you want to separate this out into your microphone track, which is there, your music track, which is there, the game audio, which is here, and then any other system sounds, which is there. So right now, all of that is wrapped up in this blue line right here. But if you want to separate these things out, you need to record each one of these things independently of the others. This is what Audacity can do for you. You can also do this in OBS if you need to, and put it on different tracks inside of the same video file, which is what I do with OBS. So OBS can, having OBS Studio can completely replace Audacity. But if you want an easy way to put this stuff into different files that you can then stack together as you want, Audacity is a really, really good way to do that. This is really all of the Adobe stuff that I'm going to be using. I'm also very familiar with Dreamweaver, but I'm also not a big fan of Dreamweaver because there's other programs that I'm going to be using as well that kind of go around Dreamweaver. Yeah. Anyway, I'm gonna take a quick little break and I will be right back. Haha, I'm back. Okay, so. Premiere Pro, Photoshop, After Effects, Audacity. What other design programs do I currently use? I think these are all the ones that I currently use. If I think of anything else, I will come back and add it to that list. But the design and streaming stuff is going to be like that, just that part right there. Because I'm primarily a programmer, we're going to be talking about programming and game design stuff. Yes, a lot of programming stuff, a lot of game design stuff. Let me turn this to that. Okay. So, under programming, let's talk about programming languages. Programming language types. Let's see. What types of programming languages do we have out there? Assembly, procedural, query, object-oriented, this is hyphenated, I think. And scripting languages. Markup languages. And then there's a new one called functional languages. And I'm going to be talking about several different languages across all of these categories. First, assembly language. Let's go back over here and talk about what assembly language is real quick. So say you have the computer, which is this box right here. This is the PC. Bam. In order to take your program, which is this right here, user program, and make it talk to the PC, there's a type of language right here called machine code. It's because the PC, as it works right now, can only operate in binary, which is ones and zeros. So machine code is binary. So you need to take your fancy programming language that has all of its words and variables and everything, and make it machine code that a PC can interact with. And to do that, you need this little purple squiggly line. This is assembly. And the green is machine code. Right? So assembly is a go-between language that converts a higher level programming language into machine code in a way that is still kind of understandable for people. You can program directly into machine code. It's horrible. It's nightmarish. I don't recommend doing it. You can program directly into assembly, but that is also horrible and nightmarish, and I don't recommend doing it. There are people who love assembly language, and let me see if I can. If you've ever done modding for a video game, you've probably seen assembly language. Because it looks like this, right? Let me see if I can't. Yeah, you've probably seen assembly language if you've done any kind of modding, because it looks like this. And what it's doing is like taking a high level function or variable and converting that into machine code. So it is very much the go-between. And when you look at, if you do like a ROM dump off of like an old regular Nintendo game, right? The computer code that they wrote the program in is not what's written on the chip that's inside the cartridge that you got. What's written on that chip is machine code that tells the machine how to execute the program that you wrote in the way that the machine can understand. So when you take that program that is on the chip and you dump it back off the chip, what it dumps the program off into is assembly language like this. So when you're reverse engineering a program, it's not like you can just go to the program and then have it spit out all the high level fancy code that you put in with comments and things explaining what everything does. What it spits out is this, just this part. This right here, these are comments that a person went back and put in explaining what each of these things is actually doing. All you get when you dump a program off of like its implementation is a list of this. And so you have to know what each of these things mean. And in cases like this, like the reason hello world is right there is because that's a variable. This is the data that was hidden inside of a variable, which in this case was a string, which is why it's written out as hello world. In a lot of other cases, it wouldn't be there. It would just be a pointer or a set of calculations to get to a particular thing. So, yeah, this is assembly language right here. It is the go-between between high-level programming and machine code, and it is not something that I'm going to be touching on much or at all. When it comes to, that's okay right there. When it comes to these tutorials, the main reasons that I'm not going to be touching on it. One, I was never formally trained in assembly language. Everything I know about it, I've taught myself, and that is not a lot. I am not an authority on assembly. I cannot look at assembly language and immediately tell you what each of the commands in the list do. I know what some of them do. I don't know even half of what these commands actually do. So I'm not any kind of authority on assembly. I'm not going to pretend to be an authority on assembly. At some point in the future, I might do some like tutorials or lessons or something to learn assembly and then stream me doing that. But right now I'm just gonna mention it and then leave it alone, because you can absolutely be a high-level programmer and know absolutely nothing about assembly language. It is not required in the slightest at all. So yeah. Procedural languages, they exist, but we don't use them that much anymore. And in fact, the main procedural language out there is C, not C++. C. It's the only real procedural language that has stuck around. I think most every other procedural language is gone at this point. Procedural languages are built around functions and step-by-step execution, right? So the program starts at the top It's like it starts at the top of the file, and then it reads this line and it does this, and it reads this line and it does this, and it reads this line and it does this, and then it goes to the next thing here, and then it reads this line and it does this, and it reads this line and it does this line and it does this, and it goes back to this, right? And it just goes down the line in one direction all the time. Following the procedure, like do this, then this, and this, and this, and then do that, and then do this, or do that, and then do this, right? Bam! It just goes down the list, and that's what it does. Procedural language. C is a procedural language, and I am going to be talking about C because I'm going to be talking about C++, and C++ goes here. As an object-oriented language, what C++ does is it takes C and it adds a bunch of object-oriented stuff onto it. It extends C with object-oriented features. And it was one of the first object-oriented languages. And C++ is still a very common language. It's everywhere. If you want to write a program that interfaces directly with hardware, you typically use C++ to do it. So if you want to know like implementations for C++, it's used all over the place in game design, specifically for games that are written for consoles. They use C++ all the time. Operating systems like Windows and Linux and Apple's what's it called? Safari? No. I forget what the Apple OS is called. Let's just be called Apple OS. But these things are written in C++ because C++ is very easy to code things that talk directly to the machine. There are things that are in C++ that are not in other programming languages. Like pointers, which lets you get in a whole lot of trouble. So we'll be talking about C and we'll be talking about C++. But the whole reason that C is on here is that in order to really talk about C++, you need to talk about the basics of it, which was in C. I kind of skipped over the query language, and there's really only one of these, and that's SQL. And that stands for, I think, sequential query language. In fact, let me Google that. What does SQL stand for? Structured query language. Okay, structured. So yeah, SQL is a structured query, is the structured query language. What SQL is for is we're talking to databases. That's it. That's what SQL does. SQL is a language that lets you talk to databases, and you use frameworks. I want to M dash. No, I want to M dash. Like MySQL. We can have cap lock on. So MySQL is a framework that uses SQL to talk to databases, right? So MySQL is a database framework that uses SQL. So I will be touching on SQL and how to use it, because if you plan on using a database, you need to know how to use SQL. And if you're going to be doing any kind of like major programming, you're going to need to have a database. Now there is an alternative to databases that I'm going to be putting in here as well, to the traditional database that will let you get around using SQL. But if you're going to be using something like C++, you're going to eventually run across SQL. Okay, now in object-oriented, we're going to be adding C#. C# is, I kind of want to say it's Microsoft's answer for Java, but although it may have started that way, it's morphed into something completely different now. C# was created by Microsoft, and it is an object-oriented programming language. It was designed to be more of a C++ alternative. But where it's currently used is in the game engine Unity. Unity used to have its own scripting language called UnityScript. But UnityScript was very much trying to reinvent the wheel. And in order to properly use UnityScript, there were like a half a dozen other things that you had to keep up to date and included in your system, and one of those things was C#, and people just started using C# to do everything that they possibly could, and UnityScript and all the baggage that came with that as little as possible, to where Unity just finally said, you know what, we're just going to remove it and make C# the language for Unity, and now it's the language for Unity. And if you're a game developer that's using Unity, C# is going to be your primary language. C# is not a language that I was formally trained in. I was trained in college on C and C++, so I know that from like a foundational level. C# is something that I've taught myself. So this is one of the ones that I'm really going to have to do some catch-up stuff on to to really get caught up with it. The other one that I have to add here that I really don't like is Java. I really don't like Java. Java is an object-oriented language, but it's not an object-oriented language that can do what either of these two languages can, right? You can't use Java to write an operating system, because Java requires a virtual machine to run. The only way that Java could write an operating system is if the hardware that operating system is running on is built like a virtual machine, like the Java virtual machine. That's the only way that you can write a. I need to double check the stream and make sure the stream is still streamering. Yes. But Java does have a really, really cool feature about it. When you write a program in C++, you are writing for an environment. So if you write your game in C++ for Windows, that's it. Your game will run on Windows. If you try to compile it and run it on a Macintosh or an Apple computer, it won't run. You have to rewrite parts of the program and then recompile it so that it would run on an Apple computer. And then you have to rewrite it again and recompile it so that it would run on Linux. And then you'd have to rewrite it again and recompile it so that it would run on a Switch. And then you'd have to rewrite it again and recompile it so that it would run on a PlayStation. Everywhere that you put your program, you have to do partial rewrites on it and then recompile the program so that it will work on the new system. So every time that you add something new to your program, you have to add it to every different version of your program and then recompile them all. It gets very complicated very quickly. C++, C# and Java get around this problem in two different novel ways. C# gets around it by writing the game for the Unity engine, and then the Unity engine itself being written for each of the environments that you're going into. So all you have to do is write your game so that it will work on the Unity engine. And then the Unity developers themselves have written a Windows version, a Linux version, a PlayStation, a Switch, an Apple And as long as your program works with Unity, and Unity works with all the different environments, you're golden. Your game's going to work in all the different environments. Java does the same thing. You write Java for the virtual machine, and then the Sun Company, which is this company that created Java, has written virtual machines for all the different environments. So as long as your game runs well on the JVM, the Java Virtual Machine, it will run everywhere that has the virtual machine installed in theory. So C# it can be used outside of Unity. It's primarily used inside of Unity these days. Java is used outside of like Unity exclusively, and Java is used for all kinds of cool things. Java can run off of applets in websites, or it can run off of games on your client side. One of the big games that was very famously built entirely in Java, Minecraft. So if you want to know what Java can do as a game programming language, look at Minecraft, because the most feature-rich version of Minecraft even today is the Java version. Things come out for Java like 3 or 4 patches ahead of what they come out of every other version of Minecraft. So, yeah. Personally, I'm not a big fan of Java. When you're doing things in full screen, Java is fine. But if you're doing like windowed applications with Java, it gets a little bit more difficult, because Java is one of those programming languages where you tell it how something should look, and then it tries to make it look like that, but it doesn't always get it right. I don't like that about Java. In C++, you can tell it, I want it to look exactly like this, and then it will look exactly like that. But then you have to do that on every version of the system. Yeah. Anyway. These are object-oriented languages that I'm going to be covering. Scripting languages, I have quite a few of these. The first one is going to raise some eyebrows, because it's kind of a scripting language, and it's kind of an object-oriented language. It's kind of in a lot of different categories, and that's Python. Python, I think it's more of a scripting language than it is anything else. That being said, it is very much an object-oriented language and can stand on its own in the object-oriented field, right? The big push for Python right now, Python is very popular, and one of the reasons that it's so popular is because it's one of the primary languages driving AI development at the moment. Lots and lots of AI stuff is written in Python. The AI chatbot that I was writing and testing out on my Discord server, I wrote those in Python. So Python, huge thing, kind of a scripting language, kind of an object-oriented language. It kind of fits into both categories. I'm going to put it under scripting, because I think it has a little bit more to do with scripting than it does with object-oriented stuff, but it's absolutely a high-level programming language, and it's used a lot in AI. So yeah, it is the primary language that I work with when I write code these days. So if I sit down to write a little program to do something, I'm probably going to write a Python script to do it. Let's see, as far as scripting languages, I'm going to also cover PHP. PHP is a scripting language that drives a lot of older website content. There is a lot of content on the web that is still driven with PHP. And if you're going to want to do any kind of full stack development, you're going to have to be familiar with this language, because you're probably going to be fixing it multiple times with just the basic upkeep of a website. You may not be creating new PHP, but you're definitely going to be maintaining it or having to look at it and then figure out how to take what the PHP was doing and turn it into a Python script. Yeah. So PHP, not because it's really used a whole lot anymore, but because it's legacy and so many things out there currently use it. If you're going to be touching on web development, and I'm going to touch on the web languages, I think PHP is one that you're going to need to know. That being said, I'm also going to cover GML, which is Game Maker Language. Language. Right. This is the scripting language that is used in Game Maker Studio. When it comes to the game engines that I myself am familiar with, the primary two that I use are Game Maker Studio because it's crazy powerful and it's a wonderful tool, especially for like early 2D games. And Game Maker Language is a scripting language that they use inside of Game Maker Studio, so I'm going to be touching on that. And then the other game engine that I use is Unity, and I've already listed C#, which is the language that is used exclusively inside of Unity. And now the last scripting language is a big one. JavaScript. JavaScript is the web scripting language. It runs both in browsers and in servers, and it's been with the internet since like 1997 or 1998. That's when I first started using JavaScript, was in 98, 99, around there. It's been with the web since the beginning. Underneath JavaScript, I'm going to list two different types of JavaScript. One is called Node, and Node is server-side JavaScript. So this is running on the back ends on the website. And the other is React, which is... It's not client-side, it's more like a library for... I guess you would call it a framework, right? So React is kind of like a framework for UIs. And I can remove that distraction right there. So when it comes to JavaScript, I'm going to touch on JavaScript, what it does and how it works, and like all the different things, the syntax and everything for JavaScript, like I'm going to do with all the other languages. But then I'm also very specifically going to talk about Node.js and React.js, because this is the primary way that JavaScript is used these days, especially React. If you're going to be a web developer, you need to know React, because it's used in everything, and it can do some crazy cool and powerful stuff. There's a website. Hold on. Let me see if I can find this thing. So, ready to have your mind blown? Take a look at this. A website called Paper Crowns. And it might not look like much, but this whole thing here was written in React. And where this site gets really cool is when you click on the background and you get this flare that kind of follows the mouse cursor and this smoke design. This entire thing is written in React and only React. This is JavaScript powering this effect right here. This website is called papercrowns.com. Go check it out. But if you want to see some of the cool things that just like React.js can do, play around with this thing. It is crazy. I will post the link to this in the chat if you want to see. This is really cool, and this is how powerful React can be. There's a lot of really cool things that you can do with it, and this is just one example of that. Really awesome effect. I don't even know exactly how they're pulling this effect off. I have some ideas for how they're doing it. But this is crazy awesome. So yeah, if you were going to be doing web design these days, you absolutely need to understand React.js, because this is your competition. Anyway, so yeah, I'm gonna be talking about Node and React. Then we got markup languages. And the main markup language that everybody knows is HTML. And the current version of HTML is HTML5. And HTML goes right along with CSS. HTML stands for the Hypertext Markup Language. And that is the language that websites are written in, and has been the language that websites have been written in since the beginning. Now, at some point in the past, there was something called XML. And XML was kind of a data storage method. And it was used all over the web for a time, even to the point that they had something called XHTML to make HTML compatible with XML, right? XML, XHTML, gone, deleted. XML is still used in some places, but in most places, it was replaced by JSON. I mentioned that there was an alternative to MySQL databases for data storage, and that alternative is JSON. That is currently the chosen data storage format that most things use. It has completely replaced XML. As of the HTML5 coming out, XML was, it's not depreciated, but it's not used anymore. Everybody uses JSON now. JSON is kind of like a markup language, but not really. It's kind of its own thing. But the way that it's written, if you understand how markup languages work, you're gonna understand intuitively how JSON works, because the syntax looks very, very similar. So that's why I've listed that here next to this. And then there's functional languages, right? I'm not gonna touch on any of the functional languages. So I think it's better that I'm going to put functional languages concepts here. There are concepts in functional languages that I'm going to be touching on, because they come into play with some of the higher level Python stuff. And like concepts like immutability, right? So this is where the data never changes. So how it works with some programs now, so you can make a variable and you have this data, and then say you want to update that, so then you delete that data and you make it this data. And then say you want to update that, so you delete that data and you make it this data, right? So you can overwrite data. That's in most languages. In functional languages, the data is immutable, so you can't overwrite it. You can only change it. So say you have like this bit of data right here, and then you want to make it something else. So that data stays the same, and then you have like that bit of data right there, and then you add this little bit of data to it. And then say you want to do something to that later, so you still have this little bit of data right there, and you have this little bit of data that you added to it right there, and then you add this little bit of data to it, right? So the data never goes away. The data is immutable. You can't delete it, you can't overwrite it, you can only like update it into a new version of the data. This idea is also the blockchain. This is what the blockchain is kind of based on. Yeah, so this is kind of what functional languages do. They're used in like very high mathematics and very math driven stuff. It's not something that the typical programmer is ever going to use. Like assembly, which is up here at the top, functional language are a very niche use case that you need to be aware of, because some of the things like pure functions, immutability, are things that you're going to need to know for high-end Python development, specifically with AI, or like the blockchain. But it's not, a pure functional language is not something that most programmers are ever going to really need to touch on. So I'm going to include concepts from functional languages as needed, but not an actual functional language. Let's see, what are the top functional languages? I used to have these right off the top of my head. I know Elixir is one of them. Elixir and F# are both functional languages. Those are the ones I know right off the bat. Because Elixir is used a lot in a lot of AI stuff. But I'm not gonna be touching on. Let me push that way down out of the way. I'm not gonna be touching on that like as specifically. I need to make everything match. I was using N dashes here. There we go. So yeah, that's the list. The programming languages that I'm going to be looking at for my own benefit, to get myself back up to speed, and for making videos on, are going to be these languages right here. I think if you pick up these, you're going to be a well-rounded full stack developer. Oh no. I clicked on something and everything vanished. Let me reopen this. Okay. And then when I actually start talking about programming, let's see, where should I start? I guess I'll start with namespace. So namespace is the inclusion of other files in your program to make your program work, and that comes down to header files. I'll come back to that in a moment. Namespaces. Now, namespace is very much a C++ thing. And it's basically to prevent naming conflicts across your code, right? So if you know you're going to be using the same types of variables, and indeed the same variables in multiple programs, you can take those variables and declare them in the namespace, and then just include that namespace by saying like using namespace common stuff, bam, right? And put that at the top of your C++. It's not capitalized, obviously. But yeah, just say, oh, I'm using this namespace. And then include the header file that has that namespace in it. And then you don't have to like declare all this stuff in every single little program that you write, because you can just use a namespace. There's a very common namespace called standard or STD that is used in nearly every C++ program ever, and it has all the basic like functions of C++. So pretty much everything C++ would be using the standard namespace, and then including other different libraries and stuff. And I guess the libraries is well, we'll leave that there. Libraries is a collection of code, and I was using the end space. This is very much a C++ thing, although it's used in a bunch of different languages. It's primarily a C++ thing. These are also called packages in Java and modules. I think they're called modules in Python. I don't know. Everything is blending together in my brain space. But libraries, packages, modules, very similar things. You have assemblies. Assemblies. And assemblies are already compiled bits of code and resources that your program can then reference, like .dll files and stuff like that. Assemblies is very much a .NET thing, but they're used in other places. I guess also in this, we'll just delete this because I will get into those when I start talking about namespaces and stuff. We need to talk about imports, which is how to bring external files or modules or libraries or headers into your current file. And we need to talk about linking, which is how you combine compiled code and libraries into an executable that can run on the system that you are on. So when I dive into the namespace and packages portion of the tutorials and stuff, these are the main things that I'm going to focus on. Yeah, so there would be at least one video on each of these things and how they work in each of the languages that that it's relevant to have it in, right? There's some languages where this is not going to be relevant. HTML, like markup languages, this is not going to be relevant. Query languages, this is not going to be relevant. Scripting languages, object-oriented languages, absolutely relevant, right? So where it's relevant, I'm going to be addressing all of these particular things within each of the languages. What would be the next objects, I guess. Okay. Classes and objects. So classes are kind of like, well, I guess they are data structures. They're a way of grouping certain sets of data together based on like custom criteria. I guess you would say. We'll start with struct. Struct is what classes were called before they were classes. Back in original C, they were called struct, which means structure, and it was a way to have a bunch of variables that all have something in common that aren't necessarily the data type. You could group them together in a struct. For example, if you were talking about a car has a bunch of variables associated with it. How many doors does it have? How many wheels does it have? What kind of engine does it have? All of these are different variables, but they all have something in common. They're all parts of a car, and you need that information. So you can make a structure called car that holds all the data relevant to the car. Yeah. And then when C++ came around, class was added right under that. So we have structs and we have classes. And classes let you put functions inside of a structure, because sometimes maybe your structure needs to do things other than just hold a random set of data that you decided was important enough to be collected together. So, bam, classes, data and methods or functions together in one. And then C# came along, C# and Java, and they added records. And I mentioned before that there was immutable data types that were used in like the functional programming languages. Records are an immutable data type. So this is for data that's always going to be the same and is never going to be able to be changed. You could put that data in a record, because you know that data is always going to be there. It's not going to be changed, like the gravitational constant of the universe or the speed of light. You can make it a record, like rules, right? You probably wouldn't. That's just the example that popped into my brain space. I'm going to mention union and enum, not because they're used. They are used, but they're not used commonly, right? Enum stands for enumeration, and it's used for a set of constants that is always a fixed set of values. And union is for storing a variable that's a data type. You can store different variables in the same memory space, but only one at a time, right? So you can make a union and have a variable that is a boolean, a variable that is an integer, and a variable that is a string, and a variable that is a floating point. And that union can be any one of those four things, but it can only be one at a time. So if it's storing a value for the integer, it can't store the value for anything else because it's currently an integer. Union and enumeration, very, very niche use cases for these, but there are use cases for them that are still used today. But it wouldn't surprise me if most programmers out there have no idea what these two are, why I've grouped them together like this, or how to implement them. What else needs to be told in classes and objects? I guess accessibility. Public, private, protected, and static. These are the different ways that you can make structures, classes, and records. You could declare them as public, which means everybody everywhere can access it. You can declare something as private, which means only things that are inside of the class can access it. You can declare something as protected, where it can only be accessed by things across the subclass or the function level. And then you can declare something static, which means it can only be accessed inside that instance of that class. And that's instantiation. Would that be... Would that be better hit in variables? Talking about instantiation? Or no? I guess I'm gonna list it here. Yeah, we'll list it here. Instantiation? That's spelled wrong, isn't it? Did I spell that right? Really? Wow. Wow. Okay. So instantiation is when you take a class and you make an instance of it to use it, like in the program that you're currently running, right? Some program languages require instantiation, some of them do not. C++, for example, does not require you to instantiate a class before you start using it. Java requires you to instantiate everything before you start using it. And the idea of instantiation is basically just copy, right? So you have a class up here. So you have the class. If you want to use the class, you have to instantiate it. That means you have to come down here and give it a name. R, right? I should probably just leave that blue so that you know. So then we have the class down here. Pretend that's a square. And now this class is named R. So now everything that this is, that is, right? Because this is just a copy of that. But now this has a name, which means this is instantiated. This is ready to use. This is not. You can't use this. It doesn't have a name or anything associated with it. This has name. It has a spot in memory ready to record all the information that comes into contact with it. It is instantiated and ready to use. Java requires this to happen. C++ actually does not. C++ will let you just pull this straight down here and start doing things with it. Java says no. Instantiate. And then you can pull the instance down here and start doing things with it. But yeah. Instantiation. Okay. I'm gonna take another quick little break and I will be right back. Hello, I have returned. Alrighty, where was I? Instantiation, that's right. There are a couple of very specific classes that I should probably mention. Instructors, destructors, of course objects, and templates. And I think that's it. So constructors, deconstructors, objects, and templates. A constructor is a special function that handles the initialization or the instantiation of a class into an object. So it's a class before it's instantiated, and then once it's instantiated, it becomes an object. And a constructor is a particular function inside of a class that is instructions for how to convert itself into an object. So sometimes certain data types need to be set up a certain way, certain variables need to have particular starting values, and the constructor handles setting up all of that stuff so that when the object is made, it just works right out of the box. The destructor is the same thing, but in reverse. When the object is no longer needed and the object is destroyed, the destructor handles the cleanup of the object. Specifically, variables that are in memory, the destructor is responsible for making sure those variables go away. If you've ever heard the term memory leak, one of the ways a memory leak happens is a destructor is either not present or not working properly. And so you create an object, the object creates a bunch of things in memory, and then you don't need the object anymore and you delete the object, but all the things that it created in memory are still in memory. And the program can't do anything about those things because that object still needs them, and it doesn't know that the object isn't there anymore. So those things are just stuck in memory for as long as the program is active. And then if it needs to make that another instance of that object, it creates duplicates of all those things. But then when that object isn't needed, because it doesn't have the constructor to delete the memory, all that stuff just stays in the memory. And then if it needs the object a third time, it instantiates it again, which creates another set of memory for it. And if this happens a whole bunch of times, you get a lot of trash just dumped up into the memory. And eventually you run out of memory and your system crashes. Bam, memory leak. It's one of the ways a memory leak happens. There are other ways. But yeah, destructors can clean up a lot of that. And an object is just the instance of a class. And a template is kind of a generic class that can fit into a bunch of different data types, but isn't like specifically okay. I'll give you an idea of a template. Okay, right, so say you have a class named Ford, and then you have another class named Ferrari, and then you have another class named Porsche. Those are different classes. Each one of those classes have particular things about them on how to make the different cars, right? But all of those classes could pull from a template called car, right? Because all the cars have things in common that all cars have. And so those things don't need to be a part of each of those classes and duplicated. They can be a part of the template class car that then these other particular styles of car use. And it doesn't necessarily need to be a car that uses that template, because other things could, depend on how generic the template is. All vehicles, for example, could use the same template, planes and boats and cars and motorcycles, if the template is generic enough, because there's things that all of those things have in common. So you can have one template that supports multiple different things. Yeah, templates. And then down here under, like, I guess you would call this behaviors that are associated with classes and such. We're gonna have the one that murders everybody's brain space. Inheritance. Inheritance is the idea that one class derives from another class. Like, for example, Ford pulls from car, and then Porsche pulls from car. So you could say that both Ford and Porsche are children of car, because they're both cars. So every Ford is a car, but not every car is a Ford. Inheritance. Right along with inheritance is polymorphism. Polymorphism. And that's basically the idea of one function that behaves differently depending on the context. Yeah. So you have one thing, and if called one way, it does one thing, but if called from another thing, it does something slightly different. Like in a video game, when you have one ability that has two different things, like if you're in combat, it does one thing, and if you're out of combat, it does another thing. Polymorphism. When you have one function that behaves that way, that's polymorphism. Abstract. Now, abstract is an interesting thing. It's a base class that can't be instantiated. It can only be extended. So I guess I should cover class extensions as well. And then interface. This isn't really a C thing, a C++ thing. But it's the idea of I guess you could say it's specifying some of the functions or methods that a class has to implement. And then there's one that a lot of people don't really know about a lot, friend. This is a feature in C++ that allows access to one class's private members from another class. So you can say that this class is a friend of this class, and then the other class can use the private functions that are yeah. Okay, I think that's everything that's in classes and objects. Friends, interface, extension, abstract, polymorphs, inheritance, instantiation. I think that's everything. What would be the next, I guess we could talk about data types. And variables. Where should I start with data types? I guess we talk about the different types of data types first. So they are primitive, and these are basic data types like int, float, character. They're derived, and these are like arrays and pointers. They're built from primitives. They're signed and unsigned, and that is specifically for integers on whether or not they're positive or negative. There's a const keyword, which means it's a constant. The value of that one cannot be changed. There's volatile. Volatile? That's right. And volatile is a variable that is not based on anything that's in the program. It's based on something that's in the hardware. So, yeah, like threading and stuff like that. A lot of those variables would be volatile. And then there is static. And static variables retain their value across multiple function calls or across shared instances. So if it's a variable that is shared between multiple instances, a static variable will keep the same value across all of those instances. And I would be going into big detail about each of these when it comes to talking about them in the video. Stretch. Yes, must stretch. Stretching is hard today because I have a pain like right in the dead center of my back. Water. I have tea, so I will hydrate with my tea. Okay. Hum. Stretch in whatever way will be refreshing. Yes. Oh. Okay. So I guess we get right into data type. So we have int, and then we have short and long, and then long. I'm not joking. These are the different size integers. And then there are floating point, which means they have decimals, and that is float, double, and long double. Characters, which is char, w char, t, char 16t, char 32t. And those are the character. And those are for like different encodings of characters. Booleans and void. So Boolean represents true and false, and void represents no value at all. And these are all very much C++ things. And then other high-level languages incur some other types. Like some languages don't differentiate between int and float. They just call it number. And then, whereas void represents no value, there is also the idea of the variable having not been sent or set. And that value is called null. And so you can create a variable that is not instantiated, which means it's not set up in memory, and that is a null variable. Some programming languages allow for that. Some allow for big integer, which allows you to arbitrarily set a precision for an integer. And then there is also one called decimal that allows for the same thing for floating point. These are mathematical things where if you need a certain like high precision decimal value for like financial calculations, you'd use decimal instead of float. And then there's any and dynamic. And this is a variable that changes its type depending on what it's holding. And some languages allow for this, like Java allows for this. And these are all called primitive data types. Then there are other data types that are not primitive. Technically, these are data structures, but everybody tends to think of them as more of a data type than a data structure, and that would be an array. An array is a collection of variables of the same type that is indexed. And then a lot of languages have something called a string, which people think is a data type, but actually it's a data structure, because a string is an array of characters in order. So string, technically a data structure. And then there's tuples. And tuples are an ordered group of elements that are not necessarily the same type. And you see these a lot in like C# and stuff like that. I think C# uses tuples. I think that's where I first encountered them. Yeah. And then there's things that'll really get you in trouble. Pointers. Now, a pointer references a variable in a very unique way, whereas an integer would reference the variable based on the name of the variable. So you could have an integer called current count that has the current number of something that you're counting. And you can reference that by the name current count, right? But you could also reference it by the pointer to current count. And that would reference that bit of information by its memory address instead of by its name, which is dangerous. Because what you're doing, so let's imagine this circle here is a hard drive, and we're gonna chop it up like a little pie, like this. And say I wrote a little bit of information right here that is like G, right? I could get to that information by referencing G in the code, and then it will look, oh, G's written over there. But I could also reference that by a pointer to G, which isn't pointing at G, it's pointing at the spot that G is in, which is currently this spot right here. So both the pointer, we'll just read it. Both the pointer and the reference are referencing G, but the point is referencing the memory address of G on the physical memory. Now, you remember when I said that you could delete things and like G isn't needed anymore, so G isn't in this memory anymore. So instead of having G here, just gonna erase that. So G's not there anymore. Let's say now this is A. Now A is in that memory spot. So, and G can be over here now. This is where the problem comes in. Now, if you reference G by name, G is going to say, oh, hey, G is right here. But if you didn't update the pointer is still going to be pointing to this memory location, which now contains the information from A. And if you start writing things to that memory location, bad things can happen. Because what if this memory location is now not being used by your program, it's being used by another program to do something. And you have this pointer that is pointing to that memory address that your program is no longer currently using. And then you write data into that address. Well, you could overwrite data that another program is using. Now, I know there's protections, but this is one of the dangers of pointers. Just an example. You could overwrite data that another program is using, causing that program to become unstable and possibly crash. Now, most programs have protections in place. They claim out a section of the memory for that program, and they only use that memory, and other programs can't touch that memory while the program is active. So it prevents you from overriding something from another program. It doesn't prevent you from overriding something from another function. So pointers can get really, really bad, really, really fast. Pointers are dangerous. And pointers don't exist in a lot of high-level programming languages. Like, you can't do them, and I don't think you can do them in Python. I know you can't do them in Java. But you can do them in C++, which is one of the reasons why C++ is used to write operating systems and things. Because sometimes you need to point at the location of something in memory rather than the name of the thing. So yeah, pointers are used for that, and then the only other thing we have are references, which are kind of like an alias of another variable. It's a C++ a C++ thing. So we went through data types, so it's natural now to cover operators. Yeah, I'm not going to go into super detail on operators right now. But let's see. How do you spell arithmetic? Arithmetic. Yeah, arithmetic operators. And these are plus and minus and multiplication and division and modulus. I think that's all. And then there's comparison operators. In fact, I'm gonna not do that. We'll just do. In fact, we'll tab all, like 3 tabs here, and start listing them out here. And comparison, and we have equals to, which is typically that. We have not equals to, which is typically that. we have greater than or less than, greater than or equals to, and then less than and equals to. I think that's all the comparison operators. So if equals, if it's the same as, if it's not the same as, if it's bigger or smaller than the thing but not exactly the same, if it's smaller, and if it's bigger. And what's next? Logical, I guess. Logical. And that would be and or not. Poop and then not. And then we have bitwise operators, and these are operators that are not in every programming language, but are used for binary bit manipulation. What are the other ones? And then shifting. I think that's it for bitwise operators. And then there's assignment operators. And that is assignment, increment and assign, decrement and assign, and I think you can multiply, assign, divide, assign, and modulus assign. Pretty sure. Yeah. And then, of course, increment and decrement. That's these. And there's a whole bunch of special operators. Calling from a class, pointer, address of, and difference. These are both operators that appeared before, but in the context of pointers, they have a double use, which is also confusing as hell. Okay. So I guess we would talk about advanced ones now. So we have size of, type of, and I guess I can put type ID here. Type of type ID. New and delete our operators. And then there's cast operators, and there's a whole bunch of these. Type is kind of its own thing, but should be included here. And then there's static cast. This is an underscore. Static cast. Dynamic cast. Greetings, Dajek. Reinterpret cast. And constant cast. I think that's all the cast operators. This is and instance of, they kind of go together. And then there's n. What other operators are there? I think we've covered everything that occurs in C++. So let's look outside of C++. There's an exponentation operator, and that is this. And then there's floor division, and that is this. And exponentation, that is is this stuff that I already know or that you're learning? This is stuff that I already know that I need to do refresher stuff on. But one thing that I'm going to start doing on as a YouTube series is I'm going to put out tutorial videos for it's a smooth operator. I'm going to put out tutorial videos for programming and different programs and streaming and all kinds of stuff. And so what I'm doing is kind of making a list of things that I need to make sure that I include both in my refresher course and eventually in the lessons that I'm going to be doing on YouTube to sort of teach these things. And I listed off the languages that I'm going to be focusing on by the types. I'm not really going to touch on assembly languages because assembly is still a very niche thing, and it's not something a lot of people need. You can be a perfectly competent programmer and never touch assembly language. Like that is actually a perfectly fine thing. I don't know a lot about assembly myself. I can't tell you what half of the little codes mean. Like I can spot some of the stuff, but not all of it. Not even close. So yeah. I'm not really going to touch on assembly. I'm going to touch on, these are language types right here, and then these are the actual languages underneath. I'm going to touch on C only as much as I need to, because I need to explain C++. And C++ is basically an object-oriented extension of C. But procedural languages aren't really used anymore. Procedural languages are computer languages that basically just read the program from top to bottom, and they go in order, and you can make them skip around. But it really just reads it from top to bottom, and it just follows all the lines. Like it executes the first line, then it goes to the second line, then it goes to the third line. It just reads it down. It's a procedure. C is very much a procedural language. C++ is an object-oriented language, which completely changes the workflow and how the languages work. Then there's query language, which is SQL, and then MySQL, which is a way of implementing SQL. And SQL stands for Structured Query Language, and this is a language that databases use, right? So if you're pushing and pulling things from a database, SQL is the language that was designed specifically to push and pull things from a database. Then there's object-oriented languages, and I picked these three languages specifically because C++ is the language that you use if you're writing anything that talks on the machine level. Anything that's going to talk to hardware, you're gonna really be doing that with C++. The other languages are very bad at talking to hardware. C# is the programming language that's primarily used in the Unity game engine. So I will be covering it because I'm also going to be covering the Unity game engine. Java is Java. I don't like Java, but I understand what it is and why it needs to be, right? And I covered this before, and we'll go over here, and I will show you about Java. What? Ooh. Put that back. Okay, so say you have a box that is a Windows box, and then you have an Apple box that is red, and then you have a Linux box that is turquoise, and then you have your DirectX box, which is purple, and you have your PlayStation, which is this yellow color, and say you have a Switch, which is right. You have these, and you write a program that is your fancy little program, and this oval is your fancy little program. If you write this program in C++, Java has some fatal security flaws. If you're bad at programming it, yes, Java has fatal security flaws. But everything has fatal security flaws if you don't know what you're doing. So this is your program, and say you wrote this program in C++, and you wrote this program for Windows. So you wrote the program, and then you compiled the program for C++. But now say you want to put your program out on Apple. So now you have to rewrite parts of the program and then recompile it for Apple. And now say you want to put it out on Linux. Well, Battle Royale. You have to rewrite parts of the program and then recompile it for Linux. And if it's a game and you want to then put it out on Xbox, well, you have to rewrite it again and then recompile it for Xbox. And then you have to do that again for the PlayStation. And you have to do that again for the Switch. And now say you want to update your program. Well, now you have to write the new program update for Windows, and then you have to rewrite the update for Apple and Linux and Xbox and PS5 and Switch. This is if you write things with C++. C# through the Unity engine and Java get around this. So Java has something called the virtual machine, and we'll make this in brown. And the VM. This is written by Sun Microsystems. They're the company that created Java. And they've created the VM for all of these things. Oh, Lojo won the Battle Royale. So now, all you have to do is write your program for Java, right? So you write your program, and your program works on the Java virtual machine. And Sun has already written the virtual machine for all of these other systems. So now you're done. As long as your program works fine on the JVM, the Java Virtual Machine, then Sun has made sure that Java works the same way on all of the other operating systems. So that you don't have to compile a different version for each of the different systems that you made your game on. You just make it for the JVM, and the JVM already has versions for all of these things, so it just works everywhere right out of the box. The Unity game engine works the same way. You write your game for Unity, and as long as it works in Unity and you're not using any custom code that is dependent on a particular operating system, then your game will work everywhere that Unity works. Lojo is right that there were some security flaws that were introduced in this level of Java development. They are primarily fixed now, I believe. I don't think they're still there. But there were security vulnerabilities in the Java virtual machine, not on every platform, just on certain ones. So the vulnerabilities wouldn't be there for Windows or Apple, but they would be there for Linux. They wouldn't be there for Xbox, but they would be there for PlayStation and Switch. Because the virtual machine, by nature of these different systems, can't be exactly the same on each one, because the architecture is different. So they have to change some things. And some of those changes introduced holes in the security that weren't there on other operating systems. Naturally, this was very important to Sun Microsystems that they fix this, because that would destroy Java if they didn't. So they were all over these vulnerabilities like the moment that they happen. And there's always going to be vulnerabilities with something like this. But yeah, this was the vulnerability thing that you heard about. And this did present problems with regards to user data. Because say the vulnerability here lets you get access to some of the user data of a particular program, of program X. And if you know how the user data is stored on Linux, and you know that program X was written for the JVM, then you know how user data is being stored on Windows and Apple too. And it can lead you to find and decrypt that information on other systems, because that information was open right here on this system. So when they're talking about vulnerabilities, that's what they're referring to. There was something here that let somebody see something that they shouldn't have seen, that let them figure out things that they shouldn't have been able to figure out here and here. And it can go outside of just one program, right? Because now that they've seen this with program X right here, they can look at program Y over here and see if the same type of information on this system is in the same place for program Y. And if it is, now they know where that information is on these two systems as well. So yeah, these type of things, this is how data breaches and stuff happen sometimes. So it's very important that they patch these vulnerabilities out of their systems as quickly as possible. And how you hear about it determines how severe it is. If you're hearing something about this and they're using the word vulnerability, that usually means that they found it first before somebody else did. Because if somebody else found it first, that you typically hear the words hack or data breach. So yeah, if you're hearing about vulnerability, that means that they realized that there was a problem before somebody else exploited that problem. Yes, it would be a breach. So yeah, they are watching this stuff like a hawk, because you have to. Any time that money is involved. Yes. So yeah, this is how C# and Java work. C# specifically, when through Unity, this is how it works. Because Unity, the game engine, takes place of the JVM. Yeah. And that's also why you can't use Java or C# to write like an operating system, because Java has to work through this thing, the JVM. It can't talk directly to machine hardware, so you can't use Java to write machine level code unless the machine is built exactly like the JVM is built. And they did try to do this at one point in the past and build a computer that was basically a JVM in a box. It didn't really work that well, but they have attempted it in the past. But if people are writing things that have to talk to on the machine level, or like operating systems and stuff, they use C++. They don't use Java or anything else. When it comes to scripting languages, I have Python listed here. Python is also an object-oriented language, and it is a very high-level language. It's a little bit more of a scripting language than it is an object-oriented language, but it can do both, and it is very high level, and I realize that. It goes into both categories, but I don't want duplicates on my list, so I put it in this category. That being said, Python is one of the cutting-edge languages right now, and a lot of the AI stuff that is in works in the world is being done in Python. Yeah, so Python is like cutting edge stuff right now. It's my primary language that I write in. So PHP is a old school scripting language for back-end control of websites. It was very popular in like the mid 2000s, like from like 2000 to like 2010, like that era of 2000s. Like everything websites use PHP. Now they've kind of they've gone away from PHP. Most things are handled strictly through JavaScript now, through Node.js. But I have PHP on this list because there is so much stuff on the internet that is being driven by PHP. If you're going to be any kind of a web developer, you need to know PHP. You have to. Because you are going to be fixing or repairing it all the time. You might not be writing new stuff in it, but you will be maintaining it or repairing something in PHP that broke, or having to look at PHP and figure out how to do the same thing in Python and then implement that. Yeah. So PHP is not something that's widely used in new stuff, but it's used in so much old stuff that you just have to know it. GML is the Game Maker scripting language for Game Maker Studio. GML, Game Maker language. And since Game Maker Studio is one of the programs that I'm going to be making videos on the game maker language is something I need to cover. JavaScript, of course, being the web scripting language, I have been using JavaScript since 1998, and that it was already around when I started using it in 98. So JavaScript has been there from the beginning. JavaScript nowadays basically comes in two varieties: Node.js, which is server-side stuff. So all the JavaScript that's happening on the back end is handled through Node.js, which is its own thing, and then React.js, which is a framework for user interfaces for the front end of websites. So these days when people talk about JavaScript, they're either talking about Node, React, or both. So of course I'm going to be mentioning both of them, both Node and React. And I showed a demo earlier of this website, Paper Crowns. If you want to see what React can do, papercrowns.com. It looks like a normal website, right? Oh yeah, you have buttons and stuff. You can click on it and the buttons get fancy. But when you click on the background, that's when you see how powerful React is. Because when you click back here, you can do this. And this interaction here with this flare and then like this little gas thing happening back here. And if you lightly touch it, you get colors. If you hold it down, it flares out bright. If you like circle it, it'll like flare up the whole screen. This entire interaction is React. This is cool. Like, this is just fun to play with. So yeah, if you're doing website design and you're not using React, you are crippling yourself, because this is your competition. This is the kind of things that your competition is doing with this. Which is, it's crazy that is this powerful. And if you want to see it, there's a website, papercrowns.com. This is just crazy. The fact that JavaScript can do this now is insane. So yeah, we go from that back to my little paint diagram. Yeah, JavaScript. It's the web thing now. And to be fair, on the Paper Crown site that I just showed you, there's a lot of stuff going on in the background besides just pure JavaScript making that happen. But the driver that is making that happen on that website is React. And I don't know exactly how they're doing all of it. Yep. So I'm going to have to get way up to date on both Node and React. And then there were markup languages, which is HTML5 and CSS. These are the websites that these are languages that websites are created in. I'm going to put a space between that and JSON. JSON is the new data storage language. XML has been completely replaced pretty much by JSON. Some things still use XML, but JSON has pretty much replaced it at this point. And then there's cascading style sheets, which make the tags in HTML look pretty, and you can do fancy things with them. And then there's functional languages, and for the same reason that I'm not really diving into assembly, I'm not diving into some of the more functional language concept things like Elixir and stuff like that. So I'm not going to be covering the functional languages because they're really niche cases for using them, but I am going to be covering some of the concepts that come from functional languages, because you use them in high level programming stuff in Python and like C# and stuff like that, especially with regards to AI. There's a lot of functional language concepts that come out in like AI and in the blockchain and stuff like that. So I'm going to be touching on some of the concepts, but not specifically the languages that are devoted to those concepts. And then I just started breaking down all of the stuff that I'm going to be teaching about each languages. Namespace and packaging, classes and objects, data types and variables right there, and operators. And this is where I was when you came in. So yeah, I was talking about exponentation. This is where you take a number and raise it to the exponent. So the number before the operator is raised to the power of the number after the operator. And floor division is just division where the number is, the answer that you get is rounded down. Yeah. And then there's this stuff here, because aside from programming, I'm going to be touching on design stuff and streaming stuff. So I'm going to be mentioning specifically Photoshop, where I consider myself an expert at Photoshop. I've got over 3,000 hours logged into that program. Premiere Pro, I consider myself a professional. I've got over 1,000 hours logged into that program. After Effects, I consider myself more of a beginner. I've only got about 500 hours in there. And then Audacity. And then I'm going to add more things to this list. The next time that I stream this, we're going to be focusing more on the design stuff. I'm going to try to get all the programming stuff nailed out this week, and then all the design stuff nailed out next week. And then there's streaming things that I'm going to talk about, which is like OBS and Sammy for streaming. The streaming avatars, which are the little characters down at the bottom that I use. VTubing and the stuff I use for VTubing. And then YouTube and Twitch stuff, specifically covering the YouTube algorithm and the YouTube copyright system, which is a joke. But I'm going to talk about everything that I know about those, and then how to use the YouTube backend and changes that they made to that. And then the same thing for Twitch. But for Twitch, it's more of a discoverability thing, because Twitch gives you a lot of powerful tools for making sure that your stream can be seen, right? And one of the things that a lot of people don't really talk about is when you stream and what you stream the most of, right? Because when you stream needs to be a bunch of things. Like, one, you need to stream when you're available to stream. But if you have multiple times available, you can get information for who is streaming what on Twitch at which times, and which times in your time zone are the most active times on Twitch. And if you stream during a time on Twitch that is not that active in your time zone, you're more likely to get pushed than if you stream during a time when like thousands of people are streaming on Twitch. So yeah, that's what that is talking about, discoverability and things like that. And then the copyright and backend stuff. And then social media for content creators. For as much as I know about it. And there's a lot of people who know a lot more about this stuff than I do. And I'm going to be learning from those people and then basically regurgitating the things that work into my own videos. But, yeah. Because not everything works for everybody, and like different content has different things that work. And then there are like other aspects that will make you a little more popular in one area, a little less popular in another area. So yeah. Right now, I'm gonna take a quick little break because I've hit the snooze button on this thing twice and Twitch is now telling me to take a break again. So I will be right back. Hello, I am back. Okay. Okay, so where was I? Yes. Other types of like advanced operators here. Floor division. String. Oh. Concatenation. Concatenation. And that is that. That's for joining two strings together. And then null coalescing. Coalescing? No coalescing? I think that's how you say that. That's double question mark, I believe. That is if the variable on this side is null, use this default value for it. Going in that vein, safe navigation is that, and that's a way for avoiding null errors. There's spread, which is for gathering arguments. There's arrow, which is for lambda functions. Lambda. Are there any other? Well, there's yield. And that goes with lock and synchronize and then monitor. And these are for more machine level things. Yield allows you to pause and resume functions. Lock and synchronized are for dealing with multi-threading. And then monitor is for thread synchronization. So this is for like dealing with threading and multi-threading and stuff. So this is like super advanced from up here. We're doing basic. This is like mega super advanced. I guess from here we would go straight into control flow. And these are the things that make programming languages. We have statements and we have loops, and then you'd have keywords, and then exception handling, I think, would go here. Okay, yeah. So right off the bat, we have the if else statement, or some languages call this the if else, the if then else, the else if. I'm rolling all of that into one, the if else statement, and then there's the switch case statement, and those are the two main statements. And then there's the for loop, the while loop, and then This loop is, I call it the do loop to make it less confusing because you have a while loop, but most people call this the do while loop. And the way these handle it, this is conditional branching. If this is true, do the first thing, else do the second thing, right? Switch and case gives you a bunch of different cases. You have case 1, case 2, case 3, case 4, and then switch catches a variable. And if switch catches the variable number 3, then it goes down to case number 3 and it does what it says in case 3, and then that's it, it's over, it goes back to where it was. If switch gets 1 instead, it does what it says in case 1, and then it goes back up to the top. The for loop is for executing a bit of code repeatedly with a counter associated with it. So you would have for I equals 7, right? And then the loop would start counting. And then when it gets to 7, the loop is over. It would run that loop 7 times, right? The while loop is basically repeat while condition is true. So you'll send something to a while loop like 1 plus 1 equals 2. And as long as 1 plus 1 equals 2, the loop will continue to run. The moment that 1 plus 1 doesn't equal 2, the loop will stop running. That's a bad example because a loop will always run in that circumstance. But while the condition that you send to the loop is true, the while loop will run. The do loop or the do while loop is basically the same thing, but the do loop always executes one time before it starts checking the condition. So if the condition is while 1 plus 2 equals 2, the while loop will never run because that condition is false. But if you put that condition for the do loop is going to execute one time, and then it's going to not run after that because the do loop always executes once. So yeah, these 5 things are the core like decision making for programs. Every program everywhere in the world makes its decisions based on these 5 things. These 2 statements and these 3 loops control every program in the world. It really is that simple. Then there are keywords like break. Break is a keyword here, and break will break one of these statements. So if you're in the middle of a while loop, even if the condition is true, if you encounter the break keyword, you're going to break the loop and go back to what the program was doing before it called for the loop. Continue is a similar thing. But continue doesn't break the whole loop. Continue only breaks that iteration of the loop. So if you're in a for loop, for example, and something on loop 3 causes the loop to not function properly, but loop 4 will still function properly, you can use continue instead of break. And when you hit continue, it'll skip the rest of loop 3 and then go back and start loop number 4. So it's just a little bit more control. And then there's of course return. For when you get to the end of the loop or the statement and you have the information that you need, you can return that information back to whatever called the loop or the function to begin with. And then there's exception handling. How to List off exception handling. I guess we just list off the keywords. There's try, there's throw. Catch, and finally. And these are exception handling. Match and when are for pattern matching. In some languages that allow for it. With and using, these on different lines, are for resource management. And then there's a few extensions for the for loop that some languages allow, which is for each, which is for looping through a collection, and range base. These are for looping through collections like arrays or data structures. Python has its own throw exception called raise. So we'll list that there. There's async and await for asynchronous programming. I'm gonna put, because there's something else here called assert, and this is for debugging. So I'm gonna put that there next to all the exception handling stuff, but kind of away from it, because this is like typical exception handling, and this one is Python only, and then that is debugging. And then all the way down here at the bottom, I'm gonna list goto, because goto is bad, but it's still there, and there are still some uses for goto, but goto is highly discouraged because goto breaks the stack, and when you break the stack, you turn pointers into inheritance confetti. Bad things happen when you break the stack. Don't break the stack. What goto does is basically every line of code in a program has a number associated to it. Goto lets you say, hey, at this point, go to line 7 and just start executing code from line 7. Forget that there are classes and things are being called in order, and there's a stack of things that you're building on top of, and then you have to unstack the stack. No. Just go to line 7 and start doing stuff over there. Forget the stack. Goto is bad. It's there, but it's a leftover from procedural programming languages where everything was basically going down the line. And I don't know if anybody remembers what I said. Oh, there was a way to make it go out of order and go back in the program. Yeah, goto is how you did that. You told it, hey, go back to line 7 and start executing from there. Yeah, goto is bad. Okay. I guess we can talk about functions now. Yeah, the first thing would just be functions, which is just a block of code. And then methods, same thing as functions. It's just called something different in some of the other languages. I guess I can call this section functions and methods. But this is just really just kind of basically functions and methods. There's something called overloading functions, which is where you have multiple functions that have the same name. There's overriding functions. This is where a subclass redefines a function of its parent class. There's inline functions, which is a function that appears just on one line. So you can actually use the function at the call site instead of having the function at a different site. There is the mother of all headaches, recursion. This is when a function calls itself. And yes, that is as mind-numbingly bad as you think it is. While you're inside of a function, you need the function that you're in to do something. So you have the function call itself from inside. Yeah. It is as confusing as you think it is. And when you start combining it with other things that are equally as confusing, like pointers, oh, it's headaches for days, especially if something goes wrong. Oh my god, you're never gonna fix it. Just start over. Recursion. Oh, recursion. Anyway, there were pure, I guess I can put pure and impure functions here. And this is basically when a function may be dependent on a state that is outside of the function of the class that it's in. So a pure function will never be dependent on an outside input, whereas an input function could be dependent on an outside state of something. The const keyword is here too because there are constant functions. There are virtual functions, which are functions that are meant to be overridden in subclasses. I mentioned these before, but there are lambda functions, which are anonymous functions that are sometimes inline defined. And they're used in a lot of high-end stuff. When I was talking about some of the higher end things that use functional languages, lambda functions are one of the things that use functional language concepts. Closures. And those are functions that capture variables from outside of their scope. So, like, for example, if it's scoped to protected, it would capture like a global variable or something like that. What am I forgetting? Oh, higher order. Higher order are functions that take another function as an argument or return a function back. So imagine if you have a function, and when you call that function, it runs, and then the answer that you get back from that function is another function. That's a higher order function. So I've already listed off all of the simple data structures. Okay, so we can do data structures now. Data structures and sorting algorithms. So I've got all the basic ones. What am I? Okay, yeah, so I think I just start from the top. We have lists and LIFO, which is stacks. I mentioned the stack, and the stack is something called a LIFO structure. And that means last in, first out. So basically like a stack. So imagine that you have a paper and you put it down on your desk, and then you have another paper and you put that paper on top, and then you have another paper and you put that paper on top. You're making a stack. And the last thing that you put into the stack is the first thing that comes off the stack. So when you start unstacking it, you start at the top and you take off the last thing that went into the stack. Last in, first out. LIFO. That's a stack. And then you have something called a queue. And queues are FIFO, which means first in, first out. And you can think of this as like a line. So people are lining up, and then the first person who got in line is the first person that gets seen that comes out of the line, right? So first person in, first person out. So you have last in, first out, and you have first in, first out. What else? I'm going to add DQs to this. And then sets, which is just a unique collection of items. Oh, maps and hash tables, which is key value storage. And then we have linked lists. And then under that, doubly linked lists. Trees, graphs, heaps, and tries. And so a linked list is a list of items, and then one of the things that the item does is point to the next item in the list. And then a doubly linked list is a list where the items point to both the next thing in the list and the previous thing in the list. A tree is basically what you think. It has something at the top, and then it has things coming off. There's something here, and there's something here, and then those have things coming off. There's something there, and then there's something there, and this has some, yeah. So this is a tree, basically. And then graphs can be like a bunch of things like this. And then a heap is a special type of a tree. And then a trie is another special type of a tree. So, yeah. I will go more into that when I'm actually talking about trees and graphs and heaps. I think that's all of the data structures that I didn't mention before. And then there's searching, and we have linear, searching, and we have binary searching, and then we have traversing. And then under traversing, we have depth first, and we have breadth first. Breadth first. And then we have sorting algorithms. And I guess we'll go from simple to more complicated. Bubble sort, selection sort, insertion sort, merge sort. That uses recursion. Quick sort, which also uses recursion, and heap sort, which also uses recursion. Counting sort. I don't know if counting is considered a sort. But then there's the radix sort and bucket sort. And those are like non-comparison sorts, those last three. There's the shell sort, which is an improvement of the insertion sort. There's the Tim sort, which is a special, I think it's Python only. It's like a hybrid sort. And then there's the external sort. And that's for sorting things that are too large to fit into your memory. Am I missing any sorts? Does anybody out there in chat land know if I'm missing a sort? I think I got them all. Can't think of any others. I think that's all. Okay, so now let's talk about some high-level concepts that I need to include that I may not have included before. Comments. Comment your code, people. Comment your code. These are annotations that are ignored by the compiler that tell other humans what you were thinking when you wrote a particular set of code. Comment your code. Encapsulation. And that is basically black boxing some of the data. Hire me. Yes. Put that in the comments, like at the top of your code, for your consideration. Yeah, we got encapsulation, composition and aggregation. Which is building objects out of other objects, and then shadowing, which is a local variable that is hiding an outer variable or a global variable. And binding is linking function calls to particular sets of code. And then scope, which is the area that a variable is accessible. Lifetime. Lifetime is how long a variable exists in memory. Mutability, because I've mentioned mutability. I think that's how you spell that. I mentioned this something to immutable, which means they can't be changed. Traits. And traits are reusable methods that can be shared across classes, kind of like mixins. Serialization. So serialization is converting objects into more storable or transmittable formats. Oh, garbage collection. I mentioned before, we'll add memory management to this. Because garbage collection is a type of memory management that sometimes you end up with a bunch of extra variables shoved up in the memory, just taking up space, and it can lead to memory leaks and stuff. Well, if you implement garbage collection into your program, you won't have memory leaks because you will be cleaning up after yourself. Garbage collection and memory management, definitely something that a lot of programmers need to take a look at because it's important. Threads and processes. Dependency. Dependency injection, which is adding dependencies to something after you've already instantiated it. Oh, deadlock and race conditions. Oop. And that's for concurrency, to avoid some of the pitfalls that you can fall into there. And then I guess debugging and testing. Debugging and testing. Self-explanatory. Web protocols. And then the HTTP protocol in particular. or we'll say requests. HTTP requests, because that's going to cover a lot of different things. What sockets? We talk about sockets when we're talking about web design there. File I/O for reading and writing. I/O stands for input output. Authenticate. Oh, we can put that here actually. Authentication and authorization. Encryption. Hashing. Hashing is one-way data transformation. A lot of people talk about hashing. A lot of people don't explain what hashing is. So this is when you take a piece of data and you transform it into something else and then save the something else. This is used a lot for passwords, right? So when a website saves your password information, they're not saving your password. They take your password and then they hash it into a long, like 64 character hexadecimal phrase, and then they save that hexadecimal phrase so that if someone does hack their system, they don't get your like real word password. They get this phrase of random letters and numbers that they need their own hash table in order to figure out what it is. And then when you type in your password, all it does is takes what you type in, hashes it out, and see if it matches the hash that's already in the database. So yeah, that's what hashing is. And if we're going to talk about secure connections on the internet, TLS and SSL, secure sockets layer. With file I/O, I'm going to add sandboxing. And sandboxing is running a code in a restricted environment. This is very important if you get programs and stuff off the internet and you don't know where they come from and you don't trust them. You don't want to run them on your main system because it could do anything. You want to create a particular place where you can run that program where if it tries to do something malicious, it can't get out. It's trapped in a sandbox, as it were. Sandboxing. Oh. Let's see. We have practices that are set down for object creation. Creational patterns. The singleton. Which is one instance, it's a global instance. The factory. And then the abstract factory. Which is like centralized object creation. You create all your objects in one place and then you use them. The builder, which is creating your objects step by step as you need them. and then the prototyping, which is instead of building a new object, you clone an existing object. Structural patterns. What do we got here? We have the adapter, which is a way to bridge incompatible interfaces. Bridge, which is connecting interfaces. It's a little bit different from abstraction. Oh yeah, composite, which is a hierarchical tree. Decorator, which is adding behavior without altering a class. Facade? I think it's called facade. It's a way of simplifying interfaces. And then proxy. And then there's behavioral. Behavioral. And we have observer. And strategy and command, I remember that one. Iterator, state. That's when the behavior changes with the state of the oh, visitor. Yeah, add operations without changing classes. And then model view controller, or the MVC. Okay. And those are just higher level, like, ideas for how to create certain types of code, because like typically if you need to do something, the way to do it has already been created and optimized, and so what these are those optimizations, and I will go into these and how to apply these optimizations in each of the different types of languages that I'm looking to do. Now, the last thing I want to touch on in this is domains. And the first domain that I really want to touch on is Git. This is for creating code repositories to track changes in your code over time. And there's a bunch of keywords associated with Git. Branching, merging, cloning, forking, pull requests, versioning. Anything else? No, but then there is GitHub, which is a free platform for hosting your repositories. And it's a good way to demonstrate your code for people who want to see what you can do. Okay. Now let's talk about AI. There's PyTorch. Now PyTorch is a flexible framework that's used for a lot for research, but also for AI design, and it's primarily with Python. And it's one of the big domains of AI design. The next one is TensorFlow, which is Google's library, and a lot of the stuff in TensorFlow is already production ready. And I mentioned earlier that I knew what they used to write what OpenAI used to write ChatGPT, and it was PyTorch primarily. There are some things from TensorFlow that are in there as well, but primarily ChatGPT was written in PyTorch, and I'm going to be showing how to use PyTorch. Then there's the funny name. This isn't hugging face. This isn't a workflow like framework or a library. Well, it is a library. But it's not like a code library. Oh yeah, it is. You can have it. It's not a framework. It's a library. It's a bunch of pre-trained AI models and tools that are open to the public to learn from. It's just a big collection of people who are excited about AI. That put a bunch of stuff online for free for you to check out. And then the last thing I want to touch on is quantum computing, right? And there are quantum programming languages. They exist, they work, and you can test them online inside special quantum environments. Or if you have a quantum computer, I guess you could just test it on your quantum computer. But there's three big ones. Qiskit, which is IBM's Python-based quantum programming language. There is Q#, which is Microsoft's quantum programming language. And then there is Cirq, which is Google's framework for how to build quantum circuits. So quantum computing is here. And one of the last things that I'm going to touch on is going to be quantum computing and the quantum programming languages. And these things are, they're a thing. This is really, really interesting stuff. If you have a foundation in programming, check out Qiskit, check out Q#. Qiskit if you're familiar with Python, Q# if you're familiar with C++ or C#. Okay, so I think that is a pretty extensive dive into programming. So next week, I'm going to dive that deep into the design and stream. I say next week, but I guess it is probably going to be next week. Oh, it might be tomorrow. I don't know. It's probably going to be next week. I'm going to dive that deep into the design and streaming aspect. And I'm going to have this list like fancified with like little explanations for what everything is. I'm gonna go back and write little explanations for each of the items on that list. And then next time we're going to expand out design and streaming into a similar list. So I will have a complete outline of what I am looking to build and what I need to get up to date on. Some of this stuff, like not so much, like Photoshop and Premiere Pro, I don't really need to get up to date with that. I've spent so much time in those programs, I could operate them in my sleep. And one of the interesting things when it comes to design and when it comes to programming is, if you don't know how to do something, just look up a video on YouTube of somebody else doing it, or pull up a tutorial, or Google something, and you can learn anything that you don't know in minutes. Yep. Oh. Okay. Anyway, I think that is where I'm going to call the stream for today. I've had 4 hours of talking about programming and AI and fun stuff, and planning out a pretty good idea of what I'm going to do to teach people how to program and stuff. Yeah. Anywho, let's see who's out there in Twitch land that we might be able to throw a raid at. Who's doing some fun stuff right now? Let's see. Ison is doing stuff. Glenn is doing stuff. You know, I don't think we've ever actually raided Glenn. So let's do a raid on Glenn. Yeah. So we're gonna raid Glenn. He is playing Arma 3. And I will be back tomorrow with the collaboration with Lady in the evening time for Thunderfolk. Yeah. So I want to thank you guys for watching, and I will catch you on the flip side. Nari out.